Welcome guys. So in this video, we want to solve this integral. So 0 to 1 ln x ln 1 minus x dx. Okay, so this problem is also commonly asked in like the engineering mathematics or some interesting like just for fun, right? So this is only this is also a funny question. Okay, because the answer will not make you astonished, right? Okay, so let's start. Okay, so in order to do this, what commonly used is that you can try to solve this by complex integration, right? But I guess it's hard. So one idea is that you want to separate, you want to use Taylor expansion on this part. So just recall that ln 1 minus x has minus n from 1 to infinity xn divided by n. So this is the Taylor series or Taylor expansion. But this is the calculus part, so it should be trivial. So 0 to 1 ln x minus xn divided by n dx. Okay, so one tricky part is that in this case, actually you can change the integral with the summation. So in this part, actually you need a technical thing in advanced calculus called uniform convergence. Okay, which is I will not prove here, but but you should view as exercise to prove that this integral should exist. So you got 0, 1 ln x xn dx. Well, okay. Okay, so as I said that there's a so now we need the results of do the 0, 1 integration ln x xn dx. So we need to have this. Let's call it in. Okay. So our result will be summation of n from 1 to infinity in divided by n. Okay. Oh, so now in the previous video I already proved in. So let's quickly see. So if somebody define in to be 0, 1 xn ln x dx, you can check I0 is minus 1. Okay. And you want to do okay, so this is in, and you want to try to directly solve it, right? Or basically try to do the recursion. So obviously you can write this xn into dxn plus 1 n plus 1 ln x, and then you use integration by part. Right, so this is dv, this is u. So formula is that u dv equals to uv minus v du. Okay, so u will be ln x, and the dv will be this, right? And the minus v du, so v is, and the du ln x differentiation is 1 over x. So you get the 0, 1, this part. And then you put x equals to 1, you this ln 1 give you 0, you put 0, this ln 0, this 0 power will dominate this, right? So easy to show that this part will vanish. So this part will vanish. So your in will be minus 1 n plus 1 0 to 1 x and dx. And then you get this, and finally you get, so in will be minus 1 negative 1 divided by n plus 1 squared. Okay. Okay, so let's go back to original sum. So from here that we can write as n from infinity 1 infinity and n plus 1 squared. Okay, so the question is what is this? What is this? Okay, which is a little bit tricky because you need to write this 1 over n plus 1 squared. So from here you know that this integral is actually converge. The reason is that this is when n grows in very large, this is basically 1 over n cubed. So by the p series test, so you know that this sum must converge. Okay. Okay, so let's oh, by the way, so sorry, I forgot there is a minus here, so it's plus. So from here that we can write as n from 2 to infinity, so change it to n minus 1 n squared. From here, okay, from here that we can try to separate it. So let's see. So 1 over n minus 1 n squared actually can be written as let's see, it can be written as n 1 over n minus 1 minus 1 minus n minus 1 over minus 1 over n squared. Okay, so let's check this. So yeah, so let's check if you write as n minus 1 n squared, then this is n squared minus n minus 1 as n minus n minus 1 Okay, so simple exercise to show. So let's see. So you get n squared minus n squared plus n minus 1. N squared minus 1. So yeah, so you see it basically is correct. So this is plus. So one can write as n to 2 to infinity, 1 over minus 1, 1 over n, 1 over n squared. Okay, and so we can separate into two parts. You get n to infinity, 1 over minus 1, 1 over n, plus n to 2 to infinity, 1 over n squared, minus sign. Okay, and this part is a famous results everybody knows. Sum from 1 over n squared is pi squared divided by 6. And but you need to minus the first term. So you get minus 1, and then this is minus. Okay, so this is this part. Okay, how about this part? So this part you see is very easy, just 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4, right? So the cross and cancel, finally everything cancel. Should left with sorry, it's 1 minus half plus 1 divided by 2. This. Okay. So this for the first part that the cross term cancel, finally you get 1. So the answer will be 1 minus pi squared divided by 6 minus 1. So answer is 2 minus pi squared divided by 6. Okay, so yeah, this is the answer. So it's amazingly that you take too long. One is x, one is long minus x, which just seems symmetric, but final answer will be 2 minus pi squared divided by 6. Okay, interesting. Okay, hope you guys feel interesting. By the way, if you want to know how to prove this one summation from 1 to infinity 1 over n squared equals pi squared divided by 6, then I have a long video that you can use only use calculus to solve it without a further series. Okay, so see you guys in a future video. Hope you guys subscribe to my channel. Thanks.